Well, good evening, everyone. Welcome back. Scott Young here, the planetarium astronomer at the Manitoba Museum. And as you can see, I am still inside under my simulated night sky. Pretty much the whole province, south end of the province, within driving distance of where I am, is socked in under cloud and also thin cirrus. Oh, somebody says they can't hear me. Let's see what we can do about that. You should be able to hear me now. How about now? Now you should be able to hear me. Let's just get everything all set up here. Sorry, we were surfing back and forth to try and get a number of different things. You still have me muted? No, James can hear me. So maybe there's an audio issue on your end. So check that out. Oh yeah, a few people can hear me. Okay, great. So yes, we are still inside. We are unfortunately socked in, so we will not have live telescope views from here in Manitoba, unfortunately. There are a number of different sites that will be broadcasting, and we'll be flipping over to a few of those. The RASC, the Royal Astronomical Society of Canada, is Canada's astronomy club, and they have centers all across the country, and many of them have events that are going on from a variety of different spots, virtual events, just like we're doing. And you would think that it would be clear somewhere. But actually, if you look at the weather forecast for Canada, the clouds pretty much hug a lot of the major centers that are out there. So we don't have a whole lot of clear skies. We are looking forward to, we will check in with a few of our center friends just really briefly. And then I'll give you the links so that if you want to visit some of those other center events, you're welcome to check them out as well. We're going to talk a little bit about the planets that are visible. I'm going to show you some images, some pre-recorded video. We'll start there because that's what I'd really hoped to go with. And let us get our nice simulated sunset. This is the sky from Winnipeg right now. If you have a perfect horizon, the sun is sitting right on it. This is right about sunset time. So it's a great time to look at the sky if it was clear. Luckily, it's always clear here in our planetarium. Again, we're using Stellarium, which is free software that you can download. When the sun goes down, and while you can't do this necessarily tonight, you'll be able to do this every other night for the next week or so to be able to see some of these planets. And then to be able to see Venus, you'll be able to do this for months. So this is just the beginning of a window of opportunity. So we'll go through how you can find these things. I like to get out at sunset because sunset is usually just a beautiful time. The sky goes through all of its colors. You can sort of get to your location where you're going to observe the stars from, and it's still bright enough so that you can, you know, if you're bringing a lawn chair or if you've got binoculars or telescope you need to set up, you can set it up in the daytime. Especially if it's new gear, you want to be able to do that in the daytime so that you've got everything all functioning. And then as the sun slowly sinks below the horizon, you can start looking for things right away. In fact, some things like the moon are visible even in the daytime. So starting now and for the next week, week and a half, you'll be able to see things like the moon even in the daytime, and you don't even have to wait for sunset. Like I say, tonight it was kind of nice because the moon was right next to the little planet Mars there. Although if you've been watching the sky with us for any length of time, Mars has been around since last summer, really. And we had a great view of it last fall, October, November. It was at its closest point to the Earth in quite a while. We had a great view through telescopes. And now it's kind of reaching the end of its visibility. It's passing around the far side of the sun from our point of view. So it's quite far away from us. It's gotten quite faint, quite small. Even in a telescope, you can hardly see anything with it because it is just so small and far away. So Mars is coming to the end of its visibility. But the other two planets we were talking about, Mercury and Venus, are coming to the beginning of their visibility. And so let's get back over right now. Perfect sunset there right on the horizon. And up and to the left. So what I like to do is mark where the sun goes down and then basically go from there at a 45-degree angle up and to the left, and that's where you start looking for Venus. Venus is actually visible if you know exactly where to look. You'll see it right at sunset. The trick is getting your eyes to focus on what is usually a pretty bright sky. But if you have a pair of binoculars that you previously have focused on the moon or something like that, as soon as the sun is down fully below the horizon, it's then safe to start looking at the sky with your binoculars, because that way you won't accidentally look at the sun and blind yourself. Once the sun is down, you start sweeping with your binoculars and you'll pick up Venus fairly quickly. Now, Venus is the brightest thing you can see in the sky other than the sun and the moon. So it's really, really bright, and usually that makes it easy to see. Right now, it's still so close to the sun that it's down low. It's down in where the sky is still bright. And so it won't be as easy to spot as it is at other times. Give it a few weeks though, and it'll be a lot easier. If we zoom in a little bit here, and I'll show some telescope pictures. This is a simulated picture, of course. As we get in closer, it takes a little bit of zooming in before the whole thing. There we go. And we have to switch to tracking mode. There we go. So it superimposes pictures of the planets here. But if you look at Venus, Venus looks like almost a full moon with just a little bit of shadow on this side. The planet Venus, like the moon, goes through phases for exactly the same reason. As the planet goes around the sun, we get to see different parts of the lit up side and the dark side. And so that is, there we go. That is the phase of Venus right now. So this actually tells us something. Venus is on the far side of the sun from us right now, with the sun in the middle. And so that's how the sun can be shining and lighting up the whole side of Venus that is facing towards us. So Venus is basically coming around from behind the sun and appearing into our evening sky. You won't see any of these swirly clouds or things like that, but the phase is reproduced properly here. We'll zoom out a little bit back to our sort of more naked eye view. I'll turn off the tracking. There we go. So if you have a clear sky in Manitoba right now, you should be able to go out and spot Venus. Folks up in the Interlake, folks around Grand Beach actually look like you might have good skies. But down here in the south, we're pretty patchy with clouds. I think maybe out farther east, the folks out by Altona, Seddon's Corner, Beausejour, places like that, also look like you have a little bit of clear skies. But I couldn't quite get out there and set up in the short break that we had. All right. As the sky darkens, we'll start to see yet another planet. In fact, here, I'm just going to artificially darken the sky. I'm just going to turn off the Earth's atmosphere. Bang. Now you can see all sorts of things. Much, much higher. Actually, I guess I don't want to quite do it this way. Adds too many bright stars. There's the moon and Mars way up there. Mercury will be right in about here somewhere. And in fact, if I just click nearby, it'll probably pick it up for me. There. Oh. Mercury. Now here's where our sun set. We sort of went up at 45 degrees to get to Venus. Now you go a little bit more of an angle upwards, more like a 60 degree to the horizon, maybe. And that's where you'll start to see Mercury. Mercury is much fainter than Venus, so you won't see it as early. In fact, I'm not sure that you will see Venus and Mercury in the sky at the same time. Venus becomes bright, but very quickly it sets. Actually, we'll just drop out of let's see what we can do here. That was an hour. Okay, so if we jump forward from right now, which is a little after 9, we jump forward to 10 o'clock. Venus is right on the horizon, but the planet Mercury is still up high enough that you can spot. So you might be able to now see them both at the same time, actually. I can't because I don't have a perfectly flat horizon like this. Remember, the tree I was talking about basically blocks this entire part of the sky. Okay, let's zoom in on Mercury. Mercury, being an inner planet, going around the sun, closer to the sun than we are, it also has phases, and it goes through the phases just like the moon does. But you'll see that Mercury is in a different position here. Mercury has already come around from behind the sun and is looping around in its orbit, so that we have a sort of a crescent phase here. So you can sort of figure out in your head the 3D layout of the solar system. There's us on the Earth, there's the sun, and then based on the phases, you can actually figure out where Venus and Mercury are in their orbits. So for the inner planets with a telescope, the phases are really the only things that you can see. It's pretty hard to see any surface details on Mercury. They're just very, very small, and it's always low down in the atmosphere. So it's hard to get a clear view. And with Venus, Venus is completely covered in clouds, so we don't see any of that stuff. But it's cool to see the phases, and just spotting Mercury is something that a lot of astronomers haven't necessarily even done. I've talked to lots of folks that have just never had the opportunity to, have a clear sky and a clear horizon when Mercury happened to be visible. So it is kind of a bit of a badge of honor to track it down. Now, let's see. Here is an image of Mercury taken by the Messenger spacecraft. And so it's a nice close-up view. It kind of looks like the moon. I mean, craters, the phase there. Basically, it's just a big gray rock in space. That's what Mercury is, just like the other object, the moon, that is going around us. Now, the one thing that Mercury doesn't have, it doesn't have those maria. It doesn't have the flat areas with lava that bubbled up and so on. So that tells us something about the way Mercury formed. Mercury and the moon probably did not form in exactly the same kind of way, because even though they've both got craters on them, their features are quite different. Kaylee's pointing out it kind of looks like there's cities on Mercury. Yeah, those craters, and especially with the lines between them and stuff like that, they kind of look like roads or canals or things like that. That's a pretty common perception when you look at an object like this, and you don't really see all the details. Your eye is just picking out a few of the things. Our brain tends to interpret things in things that are familiar to us. So that's why you see faces in the clouds, or you see pictures in the clouds. That's why we see faces in a lot of things. And that's why we see, sort of like you say, cities on Mercury or canals on Mars or things like that. It's hardwired into our brains to recognize certain things like that. Here's another shot of Mercury showing sort of a different phase. This is the crescent, again from the Messenger spacecraft that was there in orbit, giving again a little bit better view. It has the terminator just like the moon does, and that's where all the detail is. It's basically the spot where if you were standing there, that would be sunset on the planet Mercury. And so all the shadows are very, very long and drawn out, and it makes it much easier to see all of the terrain and the relief here. Let's one more picture of Mercury. Big gray rock. Now the cool thing about Mercury is that it's the closest planet to the sun. You would expect it to be very, very hot. And it is. The daytime temperature peaks around 430 degrees Celsius. Now that's not the 400 that your oven gets to, that's Fahrenheit. So the 430 Celsius, it's almost twice as hot as your oven gets. Pretty nasty. But Mercury does not have any atmosphere. Well, technically it has a very, very tenuous atmosphere of sodium ions, but that's hardly worth getting into at this point. It's really, really, basically there's no air there. Air is like a blanket for a planet. If you have an atmosphere, you trap the heat from the sun, and the air is like a blanket and it keeps all the heat close to you. Mercury doesn't have that. So basically Mercury's surface is touching the frigid cold of outer space. So sure, when the sun's shining on it, it gets really hot. As soon as you get onto the night side of Mercury, the temperature dips because, there's no sun shining and you're exposed to space. So it goes down below -100. So very, very extreme temperatures on the planet Mercury. Here's Messenger, an artist's conception of the Messenger spacecraft in orbit. It's got this huge solar shield that it has to have to keep the spacecraft in its own shadows so that the sun doesn't fry it. So it's a pretty hostile environment. Messenger did a whole bunch of orbits of Mercury, sent back basically most of the information that we learned about the planet really has come from this most recent spacecraft. Now here is Venus. This is what Venus would look like sort of close up in a really good telescope, I guess. Basically, it looks like a crescent. There's hardly any detail there. It's just pure white, a little bit of fading into the terminator there, but you can't see anything. And Venus in the evening sky or in the morning sky, if you've ever seen it as the morning star, the evening star, it's brilliant. It's so bright. It looks unnaturally bright. Whenever Venus is up, we always get UFO reports. We get people thinking the aliens have come or whatever. It is unnaturally bright, it appears. And that's because those white clouds reflect so much light that it's like the sun shining off of snow, and it really gets very, very bright. So here you have a picture of Venus sort of up against a star cluster there, and you can just see how much brighter it is than the stars. This gives a sort of a good impact of what Venus looks like. And here we have the moon and Venus in a previous appearance. So, I mean, you can't see any other stars at that point, but you can see the moon, which is bright, and you can see the planet Venus. So it's something that a lot of people get the chance to see. It gets far enough from the sun that it's a lot easier to see. And it's so much brighter than Mercury that it makes it a lot easier to see. And just like the planet Mercury, it goes through phases. This is from last May when Venus was just going down to between us and the sun, and we had a sort of a crescent view that we could see of it. This is another picture of Venus sort of close up. Again, just these featureless white clouds. Now, if you look at Venus with special filters to look at different kinds of light, you actually get a little bit more detail. This is the common picture we see of Venus in textbooks and stuff like that. I think it's an infrared picture showing you know, different layers of the clouds. It kind of looks like butterscotch ripple ice cream, I've always thought. And this is pretty much the view that we would have if our eyes could see infrared and we could see Venus right now, because that's very similar to the phase that Venus is in. If we looked at Venus through a telescope, though, there's no way you can see the surface. And so what that means is that if there's no way you can see the surface, you have no idea what's going to be there, right? Is it going to be like, what's on the surface? Is there solid, liquid? What's it going to be like? We really didn't know for the longest time. I mean, you look at Mercury, you can tell that there's no atmosphere, so you kind of get a sense, fine, there's no life there. But what about Venus? It turns out Venus is almost the same size as the Earth. People have called it Earth's twin. It's closer to the sun than us, so it should be warmer. If you do the math, it should actually be, you know, 60, 70 degrees Celsius, you know, not ridiculously hot, but certainly hotter than would be comfortable for us, but perhaps survivable. But we really didn't know. And when you don't know what's going on, science fiction kicks in, imagination kicks in, and you wind up having just a huge number of ideas that maybe aren't correct. For a while, all the way up into the 50s, it was possible that there was life on Venus, and perhaps under the clouds, it would be like a tropical rainforest with dinosaurs and lakes of oil and all sorts of crazy ideas that were based on the current understanding, you know, sort of extrapolations. Well, how do you find out this for sure? You build a spaceship, a robot, you send it off to Venus, and you have it land and take pictures. So we sent a spacecraft to Venus off in the 60s, and it got there, and it was supposed to go through the clouds, pop out a parachute, land, and then radio back. It went into the clouds, and we never heard from it again. Well, you know, it's early days of the space program. Something went wrong. That's not too uncommon. Let's send another one. We never heard from it again. Third one, never heard from it again. Finally, one of the early probes was able to radio back, these clouds, they're made out of pure acid. Oh, well, that's a problem for spacecraft, which are usually made out of things that acid can dissolve. So we had to build an acid-proof spacecraft and send that to Venus. So this new acid-proof spacecraft gets there, goes through the clouds, survives that, and then it points out, oh, the clouds are actually so thick and heavy that there's more pressure on Venus than there is at the bottom of the Pacific Ocean. And so the spacecraft would get squished like a pop can. And so we had to send another spacecraft and another and another. Exploring Venus was very expensive and one at a time. And we finally realized it's a nasty place. The temperature is 470 degrees Celsius day and night. The thick clouds trap all the sun's heat. The acid rain is out of control. The surface of the rocks are even partly molten. All the rocks are kind of flat like that because with the great pressure and the heat, they basically just get flattened out. This is one of the spacecraft that managed to survive long enough to take one picture. And I think the record for surviving on Venus was something like 111 minutes after a 5-month trip and a 2-year development cycle and all that kind of stuff. You get 111 minutes before your spacecraft is dissolved, fried, melted, and squished like a pop can. So we've stopped sending expensive spacecraft to try and land on Venus. This is actually the same image processed with more modern computers, because back then it was literally a piece of film and that's what you got. But now with Photoshop and mapping software, you can take out the distortions and all that kind of stuff. So this is what it's like on the surface of Venus. Not at all Earth's twin. There's another spacecraft that managed to take another picture. I think, yeah, 111 minutes was the record. There was one that lasted like 90 minutes, one that lasted 5 minutes. Just a nasty place. So those are the 2 planets that are in the evening sky right now. And you'll be able to spot Mercury for the next week and a half, perhaps. You'll be able to spot Venus a little bit more easily coming up higher and higher for the next several months. So there's no big rush there. The moon, of course, loops around every month. And the next clear night, we'll go live again and we'll do some moon observing because I like to be able to do that. If you want to be able to follow in with that, just, oops, sorry, pressed the wrong button. Just join us through our Facebook page or through YouTube, and either click on subscribe on YouTube, or you can click on the let us know when we go live button on Facebook. And that way, whenever we do a live event, you'll get a notification, and that way you'll be able to sort of join us. When the telescope events tend to happen very, very quickly without a lot of promotion, because it's just, oh, look, it's clear tonight, let's try this. And so if you want to join us on those, they're a lot of fun. We'll take questions, we'll look at different things, usually planets and the moon, but sometimes we'll look at galaxies or star clusters or other things like that as well. So join us for those. All right. It looks like some of the other events that we were talking about have started. I'm going to cycle through a couple of them just to give you a sense of what's out there while I talk about them. I'm not going to mirror them here because they would prefer that you would join their events, of course, and that way, that's sort of the way YouTube works. But the Ottawa Centre of the RASC is doing a big national event, and they have a whole bunch of people right now. They have someone taking astrophotographs live, and let me just see if I can flip over here. There we go. So there we have the Ottawa Centre, and you can visit them on YouTube. If you just search for Ottawa Centre or International Astronomy Day on YouTube, you'll be able to find the different events. Right now, that's a picture of a galaxy that someone has taken a picture of, and presumably their narration will be talking about all the different things going on. The folks out in Ottawa, it's a great center of the RASC, a lot of really active observers. So definitely a group to keep in touch with. And they're doing events until 10 o'clock tonight, it sounds like. The Explore the Universe, or sorry, the Explore Alliance is doing a global star party right now, and this is for International Astronomy Day. And they have all sorts of events going on as well, along with the Montreal Center of the RASC. There's somebody's observatory being talked about right now, so you can join them. That's through Explore Scientific, which is a company that sells telescopes and a bunch of other things. So explorescientific.com. I will drop all of these into the chat windows momentarily so that you can see the links. Out in Victoria, excuse me, sorry. Out in Victoria at the Dominion Astrophysical Observatory, they're going to be doing some events. And oops, actually, well, that's just the ad for their events. The Dominion Astrophysical Observatory is a wonderful facility. It's 100 years old and has this wonderful telescope in it that I had the opportunity to go and hang out with for one evening, which was just fantastic. The Center of the Universe, which is their outreach center, which is attached, is a fantastic facility as well. And so their current YouTube broadcast for tonight is through the Friends of the DAO website, YouTube channel, pardon me. And so right now it looks like they're touring the Plaskett telescope. And yeah, so DAO 1916. So it's a wonderful facility. They do tours. If you're out in Victoria and you get the chance, go and check out the DAO. They've got a great facility and just a wonderful group of people working there. So those are 3 of the events that you can definitely check out this evening. And like I say, hopefully they'll have some clear skies. The Victoria one, the DAO just started. And so it looks like they're doing their tour and then they're going to be doing some telescope viewing with the big telescope. So that's probably the one to watch if you want to see some things through a telescope. The other ones, excuse me, the other ones in Montreal and Ottawa will be doing some discussion, some observing. So there's a variety of different things that you can do there. All right. I'm going to check over here to see what we have in terms of questions. I saw a few things going by in the chat. Okay, let's see. What size is Venus compared to Earth? Says Fitzum. Well, it turns out that Venus is about 100 kilometers less than Earth's diameter. So I think Earth is 12,700 and Venus is 12,600, something in that neighborhood. I'll have to check the numbers. I'm terrible at remembering numbers, but they're very, very similar in size. Heather was asking, what are those triangle things on the Venus spacecraft? Well, that's a good question. Good. There we go. Let's take off these links here. So down at the bottom of the spacecraft, this round thing here, you have these triangle things that go all the way around. And then there's this robot arm that has, well, not really an arm. It's just an arm that fell down and digs into the ground. When they first started making these spacecraft, it would tend to tumble. And so they wanted to put some kind of fins or stabilizers on it. But because of the pressure of the Venus atmosphere, the regular kinds of things that you would use on Earth just didn't work. And so what they did was they stuck these little metal triangles all the way along the edge here, and that helped stabilize the thing as it came down so that it didn't land crazy or whatever. So the kinds of things that you would do with parachutes and so on in Mars with a thin atmosphere, it's a whole different approach when you're going into Venus, when you're essentially dropping something into an ocean. The air is just so thick that it behaves more like water than it does like an atmosphere. So that's what those triangle bits are for. And this little piece here, this is a dust cover that just came off the thing. We didn't get to Venus and find this, man-made artifact there. Good questions. Let's see. Got a few there. I'll check over to Facebook, make sure. Sorry, my second monitor died, and so I'm doing all this on one monitor right now, and it's quite difficult to see everything that's going on. Let's go back to there. Okay. So it looks like we don't have any questions over on Facebook or YouTube right now. Now, one of the things that I did want to talk about that's coming up as well, the whole point of Astronomy Day is so that you can go out and see some of these things yourself. Well, coming up, especially for folks in southern Canada, people along the American border, basically, 50 degrees latitude or a little bit higher, we're getting into the period where it doesn't really get dark at night. We get sort of it gets down to twilight, but it doesn't really get fully dark for us right around starting about now and going up right till the June solstice and then a little bit after that. That's just because of the way the seasons work, essentially. And for people farther north, it's exaggerated all the way to the point of when you get up above the Arctic Circle, you actually get the midnight sun effect where the sun literally does not set. Well, for us here in southern Canada, it sets, but it doesn't go very far below the horizon. And so the sky is still a little bit bright. The ground gets dark, but the orbital space actually stays in sunlight all night long. And so that's why we can see satellites a lot. If you've ever gone out and seen a star moving across the sky, those satellites are spacecraft around the Earth. We see them when the sun is shining up there, but it's dark down here. This time of the year, we have basically a perfect time to see satellites all night long. And we have what we call space station marathons time, where you can see the International Space Station come over 4 or sometimes 5 times a night every 96 minutes or whatever it is. So I thought what I'd do is I'd take us over to the page that I use to figure out what's up in the sky in terms of satellites. So I'll switch over here. Oops. I have to switch browsers. There we go. This page is called heavens-above.com, heavensabove.com. There's a link to it from the Manitoba Museum's website. If you go over to the planetarium section and go to the current night sky information where we list everything that's happening for the month, in there's a link to Heavens Above. And basically, it calculates where satellites are. And so the first thing you have to do is when you get there, you have to change your observing location. It probably assumes that you're somewhere else. It might figure out where you are, but you click on that section and tell it you're in Winnipeg or wherever you happen to be. And once you've done that, then all the predictions are customized for your location. And so then you can click on something like ISS, the International Space Station, and it will tell you when you can see the International Space Station going over. Tonight, for Winnipeg, you can see it at 1:13, at 2:50 a.m., at 4:27 a.m., and then tomorrow night, starting at 10:49, and so on. It's in 24-hour time, so you sort of have to make sure that you're checking that. But if you click on one of these dates, what it does is it brings you a star map. And this star map shows the entire sky at the same time. And let's just adjust this. There we go. It shows where the space station will be at different times. So this basically lets you, this is like a planetarium dome over your head that has been flattened onto a piece of paper. The circular edge is the horizon all the way around you. And the center part of the map is actually the point directly over your head. So it's a shorthand of showing the entire sky at once. And it has all the directions, southeast and southwest and so on. You hold this up over your head and rotate it until the directions match the ones that are written there. And then it sort of shows you where the sky is. Well, these space station passes are, this is the 4:30 in the morning one. And it sort of comes up over on this side, over in a little bit north of west, and then goes over into the southwest. And then it sort of sinks down into the southeast. And it takes about six minutes or so to go across the sky. The ISS is a very bright satellite. It's brighter than any of the other stars. It's almost as bright as Venus, actually. So it's getting up there in terms of brightness. And there's 7 people living on that little dot. That's what I find really fascinating. You can check on other satellites as well. The Chinese space station that was just launched, Tianhe-1. Let's see. Yeah, we can see it actually tonight at 10:30. It doesn't get very high up in our sky here from this part of the world, though. So, for example, if we take a look here, it just barely gets up above the ground and then disappears because it goes into the Earth's atmosphere or the Earth's shadow. So we don't get a great view of that one. But there are a surprising number of satellites up there, and each one of them has a name and some of them are active space missions. Some of them are pieces of junk up there that just haven't re-entered yet. There's a huge number of them. And there are, of course, the Starlink satellites. You've probably heard the recent Starlink sightings where basically there's a whole bunch of satellites all in a row going by one after the other. There was one on Mother's Day here in Manitoba. We actually saw the Starlink satellites as they were like one orbit after they were launched. So the rocket goes up and it spits out 60 different satellites into sort of a line. And eventually this line sort of starts stretching out and the satellites move away and then they start moving to their final orbits. But in the first few days, it's like there's this line of satellites all really, really close together going around. And so we had a really good view on the morning of May the 9th. We had basically 60 dots all in a line so that they were touching, moving across the sky. It was really, really eerie. So you can check on all those. They launched about another 60 of them. I guess it was 52 of them just this afternoon, just a few hours ago. So there's a bunch of more satellites up there. This is a great website for checking out the things that you can see in the sky in terms of the satellites. It also has a section on astronomy. It'll make you a star chart. If you want to tell it, the time and date, it'll make a round star chart to show you where the constellations and planets are. Really, really helpful. There's one more website that I'll show you before we sign off and head to the other events that are available to us. This one's called spaceweather.com. You might not think of space as having weather. I mean, there's no air there, but space weather refers to the interaction of the sun and the stuff that it sends off into space. The sun's radiation is kind of like a wind. We call it the solar wind, and it's kind of like weather. It's a little uncertain. The wind will gust sometimes. Sometimes you can forecast it, but sometimes the forecast is wrong, just like the weather. That's what the sun is like. And so the sun's activity can be tracked on this website. Some of it's a little technical, but the main things are along the left-hand side here. There's a picture of the sun, and it shows just how many sunspots there are. Right now, there's only a couple of different sunspots, but they have numbers and they show you where they are and so on. So this is a good way to get a sense of what the sun is doing. And then a little bit farther down on the left, I mean, there's a lot of data on this page, but a little bit farther down, there's something kind of interesting. The forecast for northern lights. The sun's activity is what causes northern lights. And so when there's a lot of solar activity, we can bet that there's going to be some northern lights coming. Doesn't always happen. Remember, it's like the weather. Sometimes it's accurate, sometimes it's not. But there are some satellites that actually watch the sun that give us a little bit of warning for good northern lights, but it's only an hour warning. So if you really want to see the northern lights, you really have to stay plugged into a website like this, or there's another one called spaceweatherlive.com that has even more detail. But this basically shows you where the northern lights are visible from right now. Tonight, it doesn't look like they stretch as far down as southern Manitoba, so I wouldn't think tonight would be a great night to go looking for northern lights from us here. But if you're up in Churchill, looks like the northern lights are right over top of you there. There's a great website called explore.org, and it has a webcam up in Churchill that shows live pictures of northern lights. and you can just click on it anytime and it'll show you what the view is. And so sometimes it's cloudy or snowing, or sometimes it's clear or daytime or whatever. But sometimes, most of the times at night when it's clear, you can see northern lights there. It's pretty spectacular. All of that comes from the sun. So all of these different things, everything from, you know, solar eclipses and the visibility of the planets and the northern lights and the sunsets and stuff like that, it all comes back to our star. And so that's kind of a neat connection of, you know, all of that astronomy comes out of this thing that is basically up in the daytime that prevents us from seeing all the other stars. Now we are, let me just check here how we're doing for, there we go, how we're doing for questions on Facebook. I have to get over to the different page here. Tomorrow I'm going monitor shopping because this is crazy. I'm trying to fit it all on one screen. Okay. For those of you that don't know, of course, the museum is unfortunately temporarily closed right now. The galleries were open for a while, and then they had to shut down when we went to the whole red alert thing. So unfortunately, that's closed. But we are doing some online stuff. You can visit us there. Yeah, it doesn't look like we have a lot of questions, so I think we're doing okay. There we go. All right, so I will sign off at this point. I'm going to put the links into the chat, and I'll leave that up for a little while so that you can see the links to get to these other sites. I'll do the same on Facebook, and that way you can visit one of the other sites. I highly recommend the event at the DAO, which is just getting underway. So that's something that should be a lot of fun. And thank you for celebrating International Astronomy Day with us. It's really nice to see so many people join us. I wish we had clear skies. We will do this again so that we can see the skies. Oh, we've got folks up in Grandview, just south of Duck Mountains. Beautiful. Do you have clear skies up there, Teresa? Is it looking nice? Nice. Yeah, it's the weather around southern Manitoba is not great, but take a peek anyway. I mean, I was surprised last night. I thought it was cloudy along the horizon, and I walked to the end of my street to get around those trees, and I just happened to get a clear spot, just in the right spot where the moon and Mercury was. So it worked out really well. Take your binoculars out and see what you can see. See Venus, see Mercury. I think Venus actually will probably be really low already, but Mercury should still be up there. Anyway, that's it for me today. Thank you very much. I will leave the stream going so that I can put those links in there. That'll take me just a couple of minutes, but I'll head back to our static image here. Thanks for joining us, and we will see you all again. Remember, every Thursday at 7 o'clock for Dome at Home, which is our weekly astronomy show. Happy Astronomy Day, and we'll see you soon.